Hello, my name is Rod Elmore, and today we're going to look at a discrete probability problem. And if you look at the particular problem we're going to deal with, it says 10% of the population has a certain antibody in their system. If 12 people are selected at random, find the following probabilities. So we have some antibodies in the population, and an antibody could be for a disease. Your body's producing that because it has to overcome that particular disease. 10% of the population. So if 12 people are selected at random, so we're going to take all the people. We know 10% of them have that antibody. We're going to pick 12 of them. And then we want to find what's the probability that exactly 3 will have that antibody in their blood. What's the probability out of that 12 there will be 3? So we're going to test that out. So what we're going to do is we're going to use a table for this one. And I got to find my calculator. Found it. Or my marker. So we want to use our table. So we're going to find a table, but this is the problem. The probability that exactly 3 have that antibody in the system. 12% of the population, we're going to pick 12 people out of the population, and 10% of the population has that. So if you look over at our binomial, this is a fairly easy problem, but once again, it's missed by a lot of people. So we're going to look at our binomial distribution, and we can see that n is 12 over here. It's the only one I have. The original table has all of them in there, but on your test, you'll be given one similar to this. So we can see that n is 12. So we've got to figure out what x and p are for our particular case. Well, x is going to have to be the 3 because we want exactly 3 have that antibody in their system. What's the probability of success? That's the p. What's the probability of success? If it's 10% have it, then that is your success rate, 10%, which is equal to 0.10. So we go over here and we look at our table. So we've got to have exactly 3. We go over to 0.1 or 0.10, and we find 0.085. So that's our answer, 0.085. So we don't have to do any calculation. We're just using our table. Could we have used our binomial binomial distribution formula? Yes, we could have. But we're just using a table here. Now the second question says, what's the probability of at least 3? At least 3. Now you got to figure out what at least means. A lot of students will look and see least and think small, but you really got to get away from that and actually think, what does the word at least? If you had to have at least $3 in your pocket, would $2 work? No, you got to have at least 3, right? So at least 3 means 3. So we're looking at 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's what at least 3 means. It doesn't mean 0, 1, 2. That would be at most 3. Then it would be 0, 1, 2, or 3. So now if we look at our table, where are all these on our table? Well, if you look, we've got at least 3 was a 0.085, and then 4 would be 0.021, and 5 would be 0.004. And then you notice these down here don't have anything in them. It's not that it's not possible, but it's just so small that we don't need to even consider it. So we've got 0.085 actually for this one. And then the 4 is 0.021. And the 5 is 0.004. And the rest are all going to be zeros, so we add those up. We get 0.110, which is 11% of the time we would expect that we're going to have 3 or more have that antibodies in their system. So that's a binomial discrete probability problem using the table. It's fairly simple, but you got to remember at least 3, and if we said at most 3, then we would go to the other side of the table. So you got to decide, make sure you interpret this correctly, and then just use your table. It should be a nice, easy problem. So try those out and see how you do on the video homework and regular homework. And thank you.